Whenever I'm asked to find the coordinate of a circumcenter, or any other point of concurrency, I'm going to start by plotting my points. So I know that t is at -2, 1. So right there. And r is at 4, 3. So here. And m is at -4, -1. Right here. Now I get to play connect the dots. I'm going to zoom in on my triangle a little bit. I know that to find the circumcenter, I have to draw in the lines that are perpendicular bisectors to the sides of the triangle. So I'm going to look and see if any midpoints jump out at me. And looking at TM, this point right here is clearly a midpoint. Okay. If that's hard for you to see, you can also use the midpoint formula. So on looking at MR then, M is at, let's see, -1, 2, 3, 4, and R was at 1, 2, 3, +4. If I add -4 plus +4, I'm at 0. Divided by 2, I'm still at 0. So I know that coordinate will be 0. And then my y's, I'm at -1 and +1, 2, 3. So 3 minus 1, I'm at 2. Divided by 2, I'm at 1. So 0, 1 will be the midpoint of MR. I'm going to jot down that this is at -1, 2, 3, 0. Now I need to figure out what the slope of those lines are. So I'm going to start by figuring out what the slope of MR is, because I know this new red line that I'm about to draw in will have a perpendicular slope to that line. So if M is at -4 and R is at +4, my x's, right, I'm going up 8 there. For my y's, let's see, I'm going up 1, 2, 3, 4. I'm going to simplify that to 1/2. Now I take the negative reciprocal, and I'll have -2. That way I know for sure that the line I'm about to draw in is perpendicular to that line. So I would be going down 2/1 like that. If I was better at drawing, it would look better. Sorry. But we're going to assume that that's perpendicular. I'm going to write an equation for that now. I have a point and I have a slope, so I can put it into point-slope form very easily. In this case, I also have the y-intercept as my point, so I'm actually going to use slope-intercept form. So I have y equals my slope -2 times x plus 1. Jumping over to TM, I already have a point there. I'm going to do the same thing. I'm going to figure out what is the slope of TM, going up 2/2. So my slope right now is 2/2, or 1. I take the negative reciprocal. Well, 1/1, when I take the reciprocal, is still 1, but I have to make it negative now. So my slope is -1, and the point I'm using is -3, 0. I'm going to put this into point-slope form. So I have y minus 0 equals -1 times x minus -3, so that becomes a +3. I don't really need to write this -0 because it's not doing anything. I'm going to take those two formulas that I just found and scoot over somewhere that I have some blank space. So I have y equals -2x plus 1, and I have y equals -x plus 3. Because I have two equations that have the same thing on one side and they equal different things, I can take those different things and set them equal to each other, right? This is the same idea as, you know, if A equals B and A equals C, I can just say that B equals C. Same idea is happening here. So I'm going to set up -2x plus 1 equals negative, and I'm going to go ahead and distribute at the same time in this step, negative x minus 3. I'm just distributing that negative sign. Solve for x, I'm going to add 2x to both sides. I get 1 equals x minus 3, add 3 to both sides, and I get x equals 4. Now remember, I'm looking for a point, so I know my answer is going to be an ordered pair. We already know x is 4. To find y, I just have to take this answer and plug it into one of these two formulas, okay? Or equations, rather. The top one looks easier to me, so I'm going to do that. So negative 2 times 4 is negative 8, plus one more, I'm at negative 7. If I plugged 4 into that second one, I would do 4 plus 3, make that negative, still negative 7. So it really doesn't matter which one you choose to use. This is telling me that if I jump back over to my graph, I'm going to quick draw this line in, and it looks something like this, more or less. That's telling me that those two red lines will meet at negative 4, or 4, negative 7. So 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, 2, 3, 4, 5, 6, 7. Way down here is where they meet. Okay. And that's where the circumcenter is for this triangle.